Given the formula for a function, we want to determine if the function is even, odd, or neither. Number one, we need to determine whether the function satisfies f of x, which is equal to f of negative x. If it does, then we would say it's even. Number two, we're going to determine whether the function satisfies negative times f of x, which is equal to f of negative x. If it does, then it is odd. Number three, if the function does not satisfy either rule, it is neither even nor odd. So for example 12, we want to determine whether a function is even, odd, or neither. Is the function f of x, which is equal to x cubed plus 2x, even, odd, or neither? So step one, okay, now without looking at the graph, we can determine whether the function is even or odd by finding formulas for the reflections and determining if they return us to the original function. So let's begin the rule for even functions. So recall that the even function up here is f of x, which is equal to f of negative x. Now f of x is the original function, which is x cubed plus 2x in question. Now f of negative x means that we need to apply the negative to the input and then substitute it into that function. So if we put in negative x and cube it, we get negative x cubed. If we put in negative x into the input, negative x times 2 gives us minus 2x. Well, if we take a look at the left side, we can see that the original function x cubed plus 2x does not equal negative x cubed minus 2x. Now, that tells us that it's not an even function, because that means that both of these would have to be equal to each other for it to be an even function. So, again, this does not return us to the original function, so this function is not even. Now, we can now test the rule for odd functions. Well, for an odd function, the rule states that if we take a negative and apply it to the function, it's got to equal to f of negative x, where the negative is applied to the input. So what does that mean? That means we have to take the negative and then multiply it by its original function. So if we take a negative sign and then multiply it by those two terms, we get negative x cubed minus 2x. Now over here, if we have f of negative x, again, we apply the negative x as an input of that function. Well, negative x cubed gives us negative x cubed, plus 2 times negative x, which is minus 2x. So because these two are equal to each other, then we can say that because of this formula, this is an odd function. So we know then that this is an odd function. Now let's verify that looking at Desmos. So let's plug in that function, which is x cubed plus 2x. So if we have x cubed and then plus 2x, well, you can see here that it passes through the origin. So that means if we rotated this the entire way back around, it's rotating it around the origin, which means that this is an odd function. So we can also verify this by looking at the graph, but in this particular problem, we needed to do this using algebra and these formulas to determine whether it was an even or odd function.